Hey, what's going on everybody? And in this video we're going to work through some vectors again. But this time we're going to add some calculus as well. And we're going to think about physics. So we're going to think about velocity. And so we're given a position vector r. And it's equal to this function for the x and y components. So 4 centimeters plus 2.5 centimeters per second squared times t squared for the x. And then 5 times t for the y component. And so the objective here is to find the magnitude and direction of average velocity over an interval of 2 seconds. So what we can do is we can plug in 0 seconds and 2 seconds and find out what the x and y components are for those two time points. So when time is 0, our vector r1 is equal to 4I hat plus 0 j hat. And then the position vector r2 at time 2, at 2 seconds, would be 2 squared, which is 4, times 2.5, which is 8, plus 2, which is 10. And then 10 plus 4 is 14 I hat, so 14 along the x dimension, and then 2 seconds times 5 is 10 j hat. And so we can subtract the difference between these two position vectors. So 4 minus 14 is negative 10. Negative 10 I hat plus 0 minus 10, which is just negative 10 j hat. And so we have here, you know what, we could do r2 minus r1. Let's do that. I think that makes more sense. Final time, but minus the initial time. So we get 10 I hat plus 10 j hat. Okay, and so that's the x and y component of the difference, r2 minus r1. And then we can find the magnitude of the difference between these vectors by using the Pythagorean theorem. So 10 over our interval. So we have to divide this by our change in t. So 2 seconds. So 10 I hat plus 10 j hat divided by 2 seconds. 2 minus 0 equals 2 seconds. So 5 and 5. So our average velocity coordinates, we could say, is equal to 5 I hat plus 5 j hat. And then the magnitude of our average velocity over this interval of 2 seconds would be the square root of 5 squared plus 5 squared, which is equal to 25 plus 25 is 50. The square root of 50 is 7.1 roughly. And so that is the magnitude of our average velocity. But we also want the direction. And so we would take arctangent of 5 over 5, which equals, because we want to know the angle, which is direction. So we use our tangent function, and we know the ratio of the sine over the cosine, or the y over the x. And so we do 5 over 5, and arctangent should give us the angle. Second arctan 5, or just 1, is roughly 45, or exactly 45 degrees. And so let's see if I am correct. Yep. According to the book, that is the answer. Now the second part is find the magnitude and direction of the velocity of the instantaneous velocity. So now we want to find the instantaneous velocity of this paste it over here, and can we use this stuff to help us find the instantaneous velocity? The velocity at 2 seconds, 1 second, and 0 seconds. Well, we could just use a derivative of this function, this position function. So we would just do d over dt of vector r, which is equal to the derivative of dt over 4 centimeter. I didn't do units here, which I should have. Average velocity should end up being meters per second. Great way to check my work would be to go back through and see that it would be centimeters per second to see that the units work out. Always a great way to check your work, but I'm not going to do that. 4 centimeters plus 2.5 centimeters per second squared, t squared I hat plus 5 centimeters per second t j hat. And so the derivative of this is going to be, use the power rule, this cancels out, constant. We get 2 times 2.5, which is 5. 5t I hat plus t gets gone plus 5. That is the derivative of this. And so at t equals 0, we get, this is j hat, we get, we want to know the magnitude? Find the magnitude and direction, yeah. So the magnitude here at t equals 0 is going to be, we get 0 I hat plus 5 j hat at t equals 0. And so the magnitude of this is just going to be the square root of 5, which is the square root of 25, which is 5. And that's the instantaneous velocity, meters per second. And this is direction's going to be arc tangent of 5 over 0, which I don't know what that is. That's could be no solution, right? 5 divided by 0. That's an error. What is the direction of this? No x direction. No x component. But there's a y component. So the angle, so it's perpendicular, right? If I think about this correctly. So it's 90 degrees. It should be 90 degrees, the angle. I'm not sure exactly how you calculate it, but the angle is 90 degrees. 5 meters per second, 90 degree angle. At t equals 1, we get 5 I hat plus 5 j hat. And we get, square root of it, we get 7.1 again, meters per second. And then the direction is 45 degrees. Exactly. Right, it's going to be the same thing as these guys at 1 second. And then at t equals 2 seconds, we get 10 I hat plus 5 j hat. And that is the square root of 100 plus 25 equals 11.2, and arctangent of 25 over 100 equals roughly 14 degrees. And so let's see if we are correct on these. Five and 90 degrees was correct. 7.1 and 45 degrees was correct. And then 11 and 27 degrees. Oh. Come on now. Come on now, we made a mistake, so this needs to be arctangent of 5 over 10. Equals 27 degrees. And there we go. So those are correct. And then the final part of this, sketch the dot's trajectory from t equals 0 to t equals 2 seconds and show the velocities calculated in part B. So we could just draw a graph of what we found here. Let's do it in yellow. So our xy. Come on. And at t equals 0. So let's say this is t. And this is position. We'll say meters. At t equals 0, we are traveling at 5 meters per second. Let's say this is 5. We'll do this actually in this color. 5. And then at t equals 1 second. So let's say right here, 1 second. We get 7.1. We'll say it's like right here. And then we get up all the way to 11 at 2 seconds. So let's say like right here. And so that's what it would look like based on what we know. That is what the velocity function looks like. And remember, we were using vectors for all of these. So this is 7, and this is 11. And cool. So yeah, that's one problem. Combination of vectors in calculus. And so with that, I will leave you guys there to ruminate over it and marinate over what we just did. And we'll see you in the next video.